So in the same way that we can add type hints to variables and to the fields of our name tuple, we can also add type hints to our function definitions, and this is going to be really, really important. So for instance, when we were playing around with the format board function in the last chapter, initially I was thinking format board. It was I defined just the parameter as board, and thinking, well, it was a string, and then later I was like, oh, well, I think actually it would be better to be a list. And in the way that Python is kind of a loose with the definitions of list and string, they're very, very interchangeable. It actually would work either way. You could pass either a list or a string. But here we can be specific that the board should be a list of strings. And so the way that you add the type definition is very similar to what we saw here in when we defined the name tuple. We defined the slot name, the name of this field, followed by a colon, followed by the type that it would be, here a list of string. And here in this function definition, I'm saying that board colon should be of the type list of string. And then after all the parameters, you can put this kind of an arrow, a dash, and then a greater than sign to make an arrow to say it returns the type string. And it can return more than one type. I mean, it could, for instance, it could return a string, comma, integer. You know, it could essentially return a tuple, right, of string and integer. And you would actually describe that using tuple, and you would describe that it is a tuple with a string in the first slot and integer in the second slot, or it returns an optional value. So an optional value is either, like optional string would either be a string or the value none, which is actually the case for our find winner function. And here our main function, the way we would define it with type hints, there would be nothing that goes in the parentheses because main takes no arguments, and then main returns none. It doesn't have a return value. The whole program exists inside of main, and when it stops, it's over. And I defined a function called getMove that takes this idea of a state and returns a new state. So it takes a state, which is of the type state, and returns a new variable of the type state. And I feel like this kind of a definition just really helps me to see exactly what I'm getting in and out of a function. So those are some more ideas that you can take into your solution. One of the things, so we can kind of get started here a little bit together, and then I would really encourage you to try to program this yourself. I'm going to go into the tic-tac-toe. Let's see, this is going to be in the 22 chapter, and I'm going to do a new PY, and I'm going to call it tic-tac-toe.py, and then I'm going to open that up. And one of the things that that's gonna be different here is there's no get args. So we can get rid of all of this. Let's see. Highlight all that. Oh boy, I'm having trouble highlighting all that. So our program is just going to run into main. And here I have some ideas like that you could, for instance, define. I would recommend that you bring in these ideas from the typing module. And let's see, I'm actually, for this, I think I'm going to go over to the solution and copy this. It'd be much easier. Let me copy this into my version. And so main is not going to, it's not going to call getArgs. And one way to set up an infinite loop is to say while true, and then you can say break, so that it will break out of your function, and then you can say print done. That might be one way we could run this program, and I can execute it tic-tac-toe, and you see it doesn't do anything, it just prints done. We could, print hey, and just so I can prove that it is going through that loop once. And so what I'd encourage you to think about is that maybe you define something that is the state of your game. So we can call it state, and it's going to be this new value of state. And for instance, instead of printing hey, I'm going to print state.board, and I'm going to run this, and we see that it prints the board and then breaks out of it. So rather than printing that board, print the format of the board as it is, using the function that you have from before. So you could actually go back to your previous version of tic-tac-toe. You can go to your format board, and you can copy and paste it. You can just bring that right into your program. I'll just maybe stick it here after the main. So instead of printing the board like that, I'm going to print format board. And we can just bring that in. And so we're already kind of building upon what we had before, but we can add, for instance, our type hints, and we can say that this is going to be a list of string, and it's going to return a string. And we can run this, and we see it doesn't actually change anything about the way the program runs, but we can run MyPy on this and see how we're doing. And so far it seems that we're doing good. Let's introduce a problem here. I've described format board as taking a list of strings, and that's what state board is. Let's instead pass state quit, which is one of the fields, and it's a Boolean value. And now let's run MyPy on this. It's oddly it's saying that's not a problem. So maybe I should look into this a little bit more before I bring it in. But so that's how we could do format board. We could also go over and bring in our find winner, because that's going to work just the same as before. We can, whoops, I'll just copy that. I can put it right here, will be fine. And rather than printing done, I could print, for instance, find winner. Actually, I should probably go copy that same bit here. And let's see how we're doing on our program. Oh, interesting. Okay, so we're getting this problem here because I'm passing this quit. That needs to be board. And let's run it, see how we're doing. Run our program. Board is not defined. Oh, I need to make it state.board. And we see there's no winner. So play the interactive version yourself. Think about how you're going to go through this while true. You're going to have this idea of a state. You're going to get a move. That's what I was doing here. Like there's this function that I defined that takes this state and says, okay, player X, here's what the board looks like. What do you want to do? And then it has to validate that move, and it has to either accept that move and move on to the next player, or it needs to register that there's an error, and it needs to reject the move, or it might need to accept the move and then realize that there is a winner. So play the game many times. Try to get all the different ways that it works, like fill up the board with a draw, and see what it does when it has a draw. See what it does when it wins. See what it does when you quit the game early. See what it does when you try to put in valid input. See if you can break the game, and then once you really understood it, see if you can reverse engineer the game to behave in the same way. And in the next video, we'll talk about the rest of my solution.